Hi, in this lesson, we're going to look at how we would factorize more complex quadratic expressions. Before we start that, we're going to just quickly look at some terminology. The first one is what a quadratic expression is. It's a term that comes up a lot, and we want to know what it is. Now remember, an expression is a set of terms which are being added and subtracted, but there's no equal sign in there, so it's not going to have an equals in there. A quadratic expression is where we have variables which don't have a power greater than 2. So something like x squared plus 3x plus 2 is a quadratic expression. But if we then had something like x cubed plus 3, this is not going to be quadratic because it has a power greater than 2, which is 3. The next term is trinomial. A trinomial is just an expression which has 3 terms. So you can see here we have 1, 2, 3. So this is a trinomial. This one here has 1, 2, so it's not a trinomial. Finally, the most important distinction to make for this video is what a monic and non-monic quadratic expression is. So monic just means that the coefficient of our x squared is going to be 1. So it's going to have nothing in front of the x squared, it's going to be 1x squared. Non-monic, on the other hand, is when we have the coefficient of x squared greater than 1 or not equal to 1. So it could be 4, it could be minus 4, it just isn't 1. Now we've looked at how we would factorize monic quadratic expressions, that's 5.2 work. Now we're going to look at factorizing non-monic quadratic expressions, and this is 5.3. We've used PSF for monic quadratics, and we're going to use a similar method for non-monics. Okay, so we're going to start, instead of factorizing, just looking at how expanding works. So if we had this expression, we can use FOIL to expand it, and we get down to this step. And we're going to get 8x squared plus 16x plus 6. Now we're going to look at how we'd factorize that. So we've taken the same expression that we ended with, and we're going to go backwards through the process. So we're going to go up like this. Now we can turn our expression into this one by just separating this into 2 parts. Now remember, when we expanded, we're going to end up with 4 terms like this. Then we can add these 2 together to simplify it, but we could then separate them. And when we're expanding, we want to separate them out. Because now that we have 4 terms, we can use factorizing in parts. So remember, 4 terms, we can use this method where we factorize by parts. So we're putting brackets here, splitting it into 2 parts, then taking out the common factor in each set, and then this whole bracket should be the same. And then we get 4x plus 2. And then 2x plus 3 is the answer. So we factorize, and that's come back to the same one here. Now you could factorize if you swapped the order of these 2. So you went 4x plus 12, you'd get a different factorization here, but it would also be correct. So this is the process we're going to look at today, and what really is the hardest thing here is working out what these numbers should be. Because you do have infinite options, but there's a way that we can work it out, and that's using a modified version of PSF from what you've been looking at so far. So usually our P would be this final term here, so our 6. However, because we have a non-monic, we're going to multiply that number by an 8, and we're going to get the number 48. Our sum is exactly the same as it used to be. It's this plus 16 here, and that's the number we get here. Now we can work out factors, and it turns out that the factors are 12 and 4. So what the PSF method helps us do with a non-monic quadrilateral is it tells us what terms to put in here. Then we can factorize by parts. Now it's actually the same thing works with a monic quadrilateral, and we'll look at that in a moment. So this is a summary of what we're doing. We're taking the product. Instead of just being this C, it's going to be A times C. Now, if you think about it in a monic, your A is going to be 1. So A times C, 1 times C is C. So in a monic quadrilateral, we just look at this term. But for this one, we're going to multiply these 2. So that's our product. And then this one here is our sum. So B is our sum. And then we can use that to find factors, and then we can factorize in parts. So here I'm going to show you a few examples, worked examples of how we do this. So we've been asked to factorize 2x squared plus 7x plus 3. We use PSF. We're going to find the product, which is this one times this, which gives us 6, and then sum as usual, is just this one, which is the 7. Now we've found factors of 6 and 1. We multiply them together, we get 6. We add them, we get 7. So we can take our first equation, break it up, so we get 6 plus 1. Notice we got the 6 here and the 1 here. So we got 6 plus 1 in the middle, and the rest is the same. Now we can factorize by parts, taking 2x out of the beginning one and 1 out of the second one. Remember, these should be the same. And then we get our final answer. So now we factorize that. And we can check that by expanding. And I'm going to do that just quickly. So we're going to get 2x squared is our first term. Then we get our outside terms, which is going to be 6x. Our inside terms, which is x. And then our last terms, which is 4. And then that becomes 2x squared plus 7x plus 4. Oh, sorry, this shouldn't be a 4. We're multiplying 3 and 1, which gives us a 3. Okay, so that's what we wanted. We're now going to factorize another one using the same method. We have our product is being the multiplication of those two. This sum here is going to be the minus 10. So we had our product is minus 24. Our sum is minus 10. We come up with factors 2 and minus 12. We use those to split up our quadratic and then factorize by parts, and we get that final answer. Now, we could have, instead of putting our 2 and then minus 12, instead decided to put minus 12 and 2. This is completely fine, and you'll get the same answer, but it will be different. So we factorize this one, and it'll come out here. So you'll notice that there are more than one way to factorize these when we're factorizing by parts. The important thing is that you can expand it to get your initial expansion. So don't worry if you get a different answer to someone else. There's more than one way we can do this, but to test it, you just need to expand it and make sure it works. I also said it works for monic quadrilaterals, and this is just an example of how that would work. So as usual, we have our product. This time we have x squared, so it's just 1 times 4. So that's our p. So it's going to be 4. And usually we would have just taken p as this number, which is 4. So that's why we can do that. Then we get our sum of 5, and we get the factors 1 and 4. Now we can split it up and use factorizing by parts, and we're going to get these factors down here, which is usually what we do. With a monic quadrilateral, you can skip these steps and just go straight to this one. But when we have a non-monic, you need to go through those steps. I hope that's made sense. If you have questions, please bring them to me. Otherwise, please have a go at the questions I give you. Thanks.